All right, hello everybody. Welcome to section 7.3. It's about similar polygons. Hope you didn't mind. Now that school's out, I've taken my tie off, and anyway, I hope that everything still seems pretty professional here. Let's begin. Section 7.1 and 7.2, we talked about ratios and proportions, which was all a setup for what is about to come. Let's talk about similar polygons. Two figures that have the same shape, but not necessarily the same size, are similar. That's what it means to be similar. There's a symbol that we'll use for similar, kind of like congruency, and it's a little squiggly thing. There's a name for it that it's escaping me right now. So if we have triangles that are similar, we could say that triangle ABC is similar to triangle DEF. That's different than saying that they're congruent. Let's talk about exactly what it means. So if two polygons are similar, their vertices can be paired so that first corresponding angles are congruent. So this is the first thing to know. This is important. If two polygons are similar, their angles are congruent. Also, if two polygons are congruent, their corresponding sides are proportional. All right, so let's take a look at this example down here. If we have pentagon ABCDE and it is similar to pentagon FGHIJ, we first need to discover which pieces and parts are corresponding. So vertex A over there corresponds with vertex F. And this one, it's pretty clear which vertices are going to be corresponding. A goes with F, B goes with G, C and H, D and I, E and J, etc. So, therefore, if the corresponding angles are congruent, angle A is congruent to angle F. They have the same measure. What's congruent with angle B? Angle G. What's congruent with angle C? Good, you're correct. Angle H. And then angle D and angle E are congruent with angle I and J, respectively. All right, moving on. Not only are the angles congruent, but the sides will be proportional. Proportional means that they have ratios that are equal to each other. So, if A over, what would A over B, segment AB over segment GF be equal to? Well, it's going to equal the measurement of BC divided by GH. So in other words, we're taking the side from the first polygon over the side from the second polygon and taking the corresponding side, setting them equal. So we can make some three other statements here since there's five sides. We can also say that CD over HI is equal to the same ratio, as well as DE over IJ or EA or over JF. So as long as you go in order, in this case I use this left one here over the right one. As long as you go in the same order, left over right, left over right, left over right, left over right, those will all be congruent. All right, next, this is a very important term. You'll be answering plenty of questions about this in the next several days. The ratio of the lengths of the corresponding angles, the lengths of the corresponding sides is called the scale factor. There's another term that some other textbooks use called the similarity ratio, and you may see both of those as we move forward. So, in the example above, if BC is equal to 18 and GH is equal to 12, then the scale factor is BC over GH would be 18 over 12. Should you reduce this? Of course you should. 18 over 12 is equal to 3 over 2, and that is the scale factor or similarity ratio. You can flip it over. We can go the other direction and say that GH over BC is equal to 2/3. That is also a scale factor. It's just important that you know which direction you're going. All right, first type of question. Are these polygons similar? Here down on number 1. Well, do they have corresponding angles? Yes. All the angles are equal to 90 degrees. Well, are the sides proportional? Well, we have these two sides are congruent, but not those. So, are they similar? No. the sides aren't proportional there, so it's not similar. Number 2, let's see what we got going on. Well, I first noticed the sides. The sides are all congruent. Well, at least there's corresponding sides that are congruent. What does that mean? And if you'll notice that both pairs of opposite sides are congruent. Oh, wait, that's a parallelogram. So if we have a parallelogram, we can then make conclusions about what these other angle measurements are. If this is 80, then the other side's 80, and then that 105 is 105. We can figure out all these angles. Let's see if they're going to be congruent. The angles have to be, or sorry, if they're going to be similar, the angles have to be congruent. They're not. No, these are not similar polygons. Let's look at number 3 together. All right, what can you tell me about triangle RST there? Ooh, it's equilateral. Ooh, look, so is the other one. So what does it mean to be equilateral? They all have 60-degree angles, and then all the sides are congruent. So yes, that is a similar polygon. Okay, let me look. I'm going to do number 4 with you and let you try 5 and 6 on your own. On number 4, we got these 2 triangles. It tells us that these are similar polygons. So that means the angles have to be congruent. What are the corresponding pieces here? Angle A there is going to be equal to angle G, and then angle B is going to be equal to angle H. So therefore, how can we figure out what angles C and I are? Well, those 2 triangles both have to add up to 180, so both of those missing angles are equal to 45. Why don't you give number 5 and 6 a shot here, and I'll show you the answers in a moment. Okay, here are the answers to 5 and 6. On number 6, the key was remembering this is a pentagon. The sum of the angles of the pentagon is equal to 540. 5 minus 2, which is 3, times 180 is equal to 540. Okay, number 7. This question is asking, are the polygons similar? If they are, write a similarity statement and give the similarity ratio. If they're not, explain. Well, number 7, they're both rectangles, so the angles are all congruent. In order for these 2 figures to be similar, the ratios of the corresponding sides have to be equal. So, does 20 over 30 equal? Does 20 over 30 equal 36 over 52? Yeah. Wait. No. One is equal to 2/3, the other is equal to 9/13. Are those equal? No. And so we do not have similar objects there. Try number 8 on your own. Is this what you got? I hope so. Okay, the next type of question you're going to see look like this, where we're going to calculate the scale factor and find some missing numbers and solve for some variables. Now this says quadrilateral ABCD is similar to quadrilateral. Now it's got this different kind of symbol here. What that means, the A with an apostrophe, we call that A prime. So this is called quadrilateral A prime, D, B prime, C prime, D prime. It doesn't exactly roll off the tongue, but what it does is it very easily matches up the corresponding angles. So you first need to figure out what the scale ratio is, the scale factor rather. AB and A prime, B prime are given, so the scale factor ends up being 24 over 20 reduces to 6 over 5. This is now going to be the key to figuring out what X, Y, and Z are. All right, so 30 over X, BC and B prime, C prime give us the proportion that we need. 30 over X equals 6 over 5. From there we can solve and get that X is equal to 25. And then we'll continue. DC and D prime, C prime give us Y over 15 equals 6 over 5. The only thing to be careful of here is make sure that since this is 6 to 5, left to right, that we just have to make sure we go in the order. If you get these things backwards, you're obviously going to get the wrong answer. So y ends up equaling 18 when we solve by cross multiplying. And then we'll do the same thing for z. 27 over z equals 6 over 5. Solve and get z is equal to 45 over 2. You're going to get fractions. I prefer fractions over decimals for your answers, and I don't mind you using your calculator to figure out what those fractions are equal to. Okay, try 7, 8, and 9 down here, and then we'll talk about it. All right, these are these answers. Hopefully those are the ones you got. All right, we got the last set of questions down here. Hey, I'd like to figure out who's paying attention. So if you are paying attention, will you draw a smiley face in the middle of this little quadrilateral right here? And again, don't tell your friends. This is how I know who's doing exactly what they're supposed to be doing. All right, what goes on here? This question asks us to do three things. Find the scale factor, the perimeter of quadrilateral GEOM, and then the perimeter of G prime, E prime, O prime, M prime. To do this, they have to give you enough information to find the scale factor. In this case, we have to make sure we're matching up the 18 and 24. Those are the corresponding sides. So that gets us the scale factor of 3/4. The perimeter then is going to follow the same scale factor. So we just found the scale factor. So the perimeter of GEOM is 18 plus 24 plus 21 plus 27 equals 90. That's the second part of the answer. That's not difficult. Really, nor is the next part. It's just we're going to have a proportion. To figure out what the perimeter is, now they offer this awesome idea of first you can find what G prime E prime is, and then E prime O prime, and then O prime M prime, and then add them all together. Well, that would be a serious pain when all we have to do is figure out, is put the sum, the perimeter of the first one over the perimeter of the second one, creating this proportion. The scale factor is 3/4 equals 90 over x. Solve for x, you get 120. That is a much, 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 much simpler way to go. Let me help you get set up here on number 10. We got triangle ABC and then triangle A prime, B prime, C prime. Their scale factor is 7/9. The perimeter of ABC is 42. So we're going to write this proportion. Just be careful with the order of what you do, but we'll say 7/9 is equal to 42 over P. Then solve for P. The perimeter is going to end up equaling 54. Try 11 and 12, and then you're done. Okay, these are the answers. Come ask me questions if you have them. Hopefully this is making good sense. We'll do some practice, but make sure you get some rest and hunker down from those tornadoes, will you?